Hello everybody, welcome to another episode of me solving some Leetcode questions, kind of preparing for some of those high-level interviews, I guess. Let's see what type of questions do we want to choose today. You want to pick this one? Okay, I guess we're doing this one. Let's see, 1221. Split a string in balanced strings. Balanced strings are those who have equal quantity of L and R characters. Given a balanced string S, split it in the maximum amount of balanced strings. So I have a string, a balanced string, have equal amount or equal quantity of L and R characters. Okay, let's see. Our input would maybe look like this, right? R L R L R R L L R L R L. Our output would be to return the maximum amount of splitted balanced strings. Given a balanced string, split it in the maximum amount of balanced strings. So for a balanced string, you would need basically the same amounts. So if we have an amount of L and R characters, the only way we can build different balanced strings would be, as given in the explanation, you would have to pick one of each, and then the next unique one would be to pick two of each. This can be split into RL, RRLL, RLRL. Each substring contains the same number of. Okay. Oh, I see. I was thinking about combinatorics in this case, but they really don't want you to reorder any of those characters. You cannot really pick them freely. So in this case, we will basically, it's kind of like a fizz buzz type of thing, right? You're going for the fizz, then buzz, then fizz, buzz, buzz, fizz, buzz. Or, well, no, yeah, RL, yeah. So what are we doing? We should devise a plan, right? Maybe we can actually look at the other example just to see. Looking at the examples, well, in this case we're given examples, right? This is very easy to kind of help us plan ahead. This is I mean, it's something that's made easy for us. Otherwise, you would kind of have to do this in your head. We could go and we start looking at R, and when we start with an R, basically when we start with one of those characters, we kind of have to look all the way until we find the other one, right? So we count one R, so we can only do one L. Good. Then we count 3 L's, and then we switch, so we can only do 3 R's, and we find 3 R's. If we had to find only 2 R's, then I guess we would only be able to use the other 2 L's from here, right? So it's like LLRR, and this would be a fail. In this case, it's actually we find 3 of them, so we back 3 of them, and then we switch again. So we basically have to know when we are done here, and then we go to the next one, right? Okay, it's an interesting question. Let's see some of the constraints. So the length of the string could be maximum of 1000, minimum of A1. A minimum of 1 would not give us, basically would give us a, we could basically, sometimes you could kind of like sketch up your cases if they are very, very short, right? In this case, if length of S is 1, we will definitely return a 0 because we cannot have a balanced string with only one element. We can actually quickly test it if we so like. I mean, it's an easy way to test it, so why not just run this, and just to kind of verify it's what they wanted. Well, as it's not balanced, and this is exactly they say that a length of s being at least 1, so I'm not sure why they would say that the length can be 1, since not thinking of any other case. Well, maybe you could basically do a z, I don't know, something that doesn't contain L or R, right? I'm not sure if that would work in this case. Invalid chair. So yeah, okay, I'm sorry. Should have seen the other constraint. They say it could only contain an L or an R. So doing this or doing this didn't work. So I'm assuming that would mean that the length would be at least 2. So some small error here. Never mind. I would still leave this condition, although I don't really see a use case. But anyway. So how can we handle doing the actual counting, right? We are going through a, so first we would loop, well, I'm not sure if drawing that stuff is working good. So loop through string, yeah. Our second step, well, what is this? Where's my, this is my brush, right? Yes. Okay, what would we do for the second step? So we would basically be having a string, right? LR, LR, for example. We only need the count of valid balanced strings. So we need some, at least we need some way of knowing that when I'm thinking in Python, there's always kind of like this way of just thinking about the problem in a mathematical way. Like, can you do something with logic on a more like a mathematical level without actually using mechanical type like counters or like, you know, just temporary variables on the side that will help you. I don't think we could find anything mathematical that would help us. Like, we cannot really go, no, we still definitely have to kind of go through each character, save them in a buffer, or at least their state, and then we can complete those substrings if they are to be completed. So if we have this, and the next case would be, you look here, you find 2 L's, you find 1 R, and then it's another L, right? For example, we have something like this. We have 2 L's, another R, a R, and an L. We should definitely pack this, right? Like, this is for sure. And then when you pack this, you basically have to, you pack it after you see an L in this case, because you're looking for the second R for this one, but you don't really find it. Do you even need that? Because every time you find the other character, that means you are actually transitioning into another substring, you don't really have to give the substrings out. You just need to know when you transition, right? So this is kind of like the abstraction that kind of simplifies the solution, I think. You only need to take care of knowing when there is a transition. So if there was another R, you wouldn't really see a transition. When you find the transition element, which is like the next flip, you basically count that as a valid substring, balanced substring, even though you had to kind of take only this, and this is kind of left out. Not sure if they have an example of this. No, this is very balanced. This is also very balanced. What about this one? 3 R's, 2 L's, exactly. So how many do you find here? There is 1. Then we go R, R. We are looking for the break string. So this is where we find the switch. We find 2 for 3. I'm just going over my logic first. I know they kind of mentioned that it's not the same, but I just want to see what I was going for initially. So we would basically see 2. I would say this is a valid one, and I'm going to the next one, and the next one would be 1 R. So I'm looking for another element, would be another L, and that would be my stop. But what they mean, oh, I see. What they did was they basically say S can be split into the first one, and then R, 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 L, 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 R, L, L. So the whole thing, since each substring contains an equal number of L and R. Okay, so they don't really even care about the order, they just want to count them. Maybe I'm approaching the whole problem from a bad angle. They really need the count, but if you are going for the count, wouldn't you be able to say there is only 1, for example, because putting a couple here makes the same thing, same quantity of R and L. What about, they say there are like 4 of those and 4 of those. This can be split into R, R, L, R, R, L. Since each substring contains an equal number. That doesn't make much sense to me right now, because you could also split it into a smaller amount, like into a substring. Okay, I see. So you cannot really split it into a substring containing. So they really go from left to right, eh? Okay. That doesn't sound like an algorithm. That is easy to achieve. Like, for example, for a question that says easy. Okay, never mind. How would we go for this one? There's definitely a counter thing, and the counter would basically count towards either the R's or the L's, right? That's how they solve it. So, for example, the right counter here, for example, here at the beginning there would be a counter for R1, a counter for L1, and that would basically complete it. So we could basically scrap that idea and write a new one. We're still looping, right? But there are like 2 counters, counter R, and let's not angry people that have some mild form of OCD or whatever. And the first counter for L, for example, in this case, the first counter for R would have a tick, and then the second counter, when the second counter also gets the same amount of ticks, that means we are getting a substring. Valid substring. Okay. then can I do something like this? I guess, I'm not sure. Then if we have for the second one, we have again R and L. So we are just continuing to loop. We get R, we get another R, we get another R. And the program continues to loop. So we get an L, we get an L. I mean, assuming this is what the solution would be, it's a very simple one because you're only looping. I'm really hoping if you are at an interview and they tell you something like this, that they actually explain you how they approach the substrings, because the only way we got this was by looking at the examples and not really by looking at this thing, right? They don't really say that you cannot discard substrings that don't fit the pattern and whatnot. So we did here like the 3 R's, 2 L's, then we do another R, and as you can see, counters are still kind of unequal, right? So we do an L, and after we do the next L, which is the last character here, then they equalize, then you basically get a valid substring. And yeah, I think this is the way to approach this algorithm, and I think it will be pretty easy to solve. So basically loop, we have the counters, we basically have to take care of the counters at each iteration. So for char in S, yeah, basically let's have the counters already. Left count equals 0, right count equals 0. If char equals L, left count looks like 1, looks like plus equals 1. I'm sorry if I didn't pay attention. Maybe I'm using some of the German terminology for some of the stuff. I'll try to gradually switch over to English. Yeah, I didn't even pay attention that it was happening, so sorry. So they say the characters are either L or R, right? So we can basically do this. Right counter plus equals 1, and after we update that, we also for each char basically we look at if left counter equals right counter. We also have an out plus equals 1, right? If we get a case where we have to update the counter, well, we could either reset or we could just continue counting, because they are basically always the only thing we are looking is when they are equal, right? So we can basically leave it at that. And I think this is the only thing that you have to do for this this thing for it to work. So let's test one case. And why do I think this is that simple? I mean, the algorithm has been abstracted into working only with very few things, right? It only updates two counters and looks if they're equal, and according to this is basically the solution. This should give us the solution. So let's try it out. This is the first one. Let's run it, see what we get. And output none, because I didn't output anything. Let's do like this. And yeah, we can simplify the algorithm, but I think it's been a bit too much time recording this. I don't even know where to look for. Anyway, oh yeah, something like this, right? 20 minutes. Yeah, I think simplifying this one would not happen this time, but at least we see that we get results. Let's try another one. And then let's try this one as well, the more complicated one. Although the algorithm now seems pretty trivial once you think about it this way. They didn't even specify that you don't really need to shuffle things around. Like I was thinking, like this would be a balanced string that really only has 3 L's on one side, 3 R's on the other side, or vice versa. But anyway, we got the output that we wanted. Let's submit it. And yeah, it's a success. So what's the take home lesson here? I guess take as much information as you can from what you're given, and try to figure out the exact intent of the question, because for each type of question, like human language is the not the perfect medium in relaying logical information, like logically structured information, because there are many things that you can say, or for a single thing that you say, there are oftentimes multiple interpretations. That's how natural languages are. And yes, I think this is the first problem that we had to kind of overcome. And the second one is, if your initial design doesn't work out, yeah, just try another one. Try to abstract away complexity and have a very simple approach to handling those problems. And yeah, I think that was all. So see you guys next time.